You have to factor the polynomial by grouping and check your answer. Well, the reason I'm going to group is because I have 4 terms. But before I start grouping this, I notice that 2, 4, 6, and 12 all have a common factor of 2. So the first thing you do on any factoring problem is you divide out any common factor. So I'm going to divide out the 2. So that's going to leave me with 2 times m cubed plus 2m squared plus 3m plus 6. And now I'm going to group within that problem. So I'm going to group the first 2. I'm going to group the last 2. So I'm kind of going to ignore this 2 on the front for right now. I'll come back to that at the very end. So when I do this, my greatest common factor between m cubed and 2m squared, the only thing they have in common is an m, and the lowest exponent of the m's is m squared. So I'm going to pull out an m squared, which means I divide each of these by m squared. So the 2 m's on the bottom are going to cancel 2 of the m's on the top, leaving me with an m on the top. That's really 2 divided by 1, which is 2, and the m squareds cancel each other out. So now just to check it, m squared times m is m cubed, m squared times 2 is 2m squared. Then I do the greatest common factor between 3m and 6, which is a 3, so I divide out a 3. So 3m divided by 3, the 3's cross out, leave me with an m. 6 divided by 3 is 2. Now that is not factored because I have a plus sign outside the parentheses. But what I notice is my 2 factors, my 2 multiplication problems, have the same thing in common. They have an m plus 2 in common. So I can divide out an m plus 2. So now my GCF is m plus 2. I can divide out an m plus 2 here. I can divide out an m plus 2 here. So those are going to cross out, and that leaves me with m squared plus 3. But if I go to factor this, m times m squared is going to be an m cubed, but I have a 2m cubed. So I have to make sure I go back and put that 2 back on there. So now if I did m times m squared, that'd be an m cubed, times 2 would be 2m cubed. My outsides are 3m. If I double that, there's my 6m. My insides are 2m squared. Oh, if I double that, I get 4m squared. My last times my last, 2 times 3 is 6. If I double that, I get 12. So I know I've got the right answer. Number 24. So what I notice on 24 is there's no common factors. So I can just automatically start grouping on this one. So I can group the first 2, I can group the last 2. 3r and r squared have a common factor of r. So I can divide out an r. The r's cross out, leaves me with the 3. The r on the bottom will cancel one of the 2 r's on the top, leaving me with 1 r. So I have minus r. Common factor between 2r and 6 is 2. So I can divide out a 2. 2's cross out, leaves me with an r. Negative 6 divided by 2 is negative 3. This is not factored because I have a plus sign outside the parentheses. But I almost noticed that I have something in common. 3 minus r and r minus 3 are opposites. So if I multiplied the 2 by negative 1 and the parentheses by negative 1, negative 1 times negative 1 is really positive 1, so I'm not changing anything. So I can rewrite this as r times 3 minus r. Positive 2 times negative 1 is negative 2. And then if I did this, r times negative 1 is negative r. Negative 1 times negative 3 is positive 3. If I wrote that the other way around, I could put the 3 first and the negative r last, and now my parentheses match. This is not factored because I have this minus sign outside parentheses. But now in common is a 3 minus r. So I can divide out that 3 minus r. When I divide it out, I'm left with r minus 2. If I'm going to write the prime factorization of 150, that's redo a factor tree. So when something ends in a 0, you know 10 goes into it. So I know 10 times 15 gives me 150. 10 breaks down into 2 times 5, which are both prime numbers. 15 breaks down into 3 times 5, which are both prime numbers. So I can say 150 is equal to 2 times 3 times 5 times 5. Or if you wanted to shorthand it, you could do 2 times 3 times 5 squared. I'd accept it either way. If I want to do the GCF between 30 and 40, well, I look at it and I think, oh, well, I know 10 goes into both of those, so I think the answer is 10. if you really want to make sure that you're right, you say 30 can break up into 3 times 10, but 10 is 2 times 5. 40 can break up into 4 times 10, but 4 is 2 times 10, and or 4 is 2 times 2, and 10 is 2 times 5. So I've prime factored my 30 and my 40. They have in common a 2, they have in common a 5. So my GCF is 2 times 5. So I was right when I said it was 10. So if you can do it mentally, that's how I want you to do it. Between 9s and 63s cubed. Well, I know that my greatest common factor cannot be bigger than my littlest number. So the highest it could be is 9. So I'm going to ask myself, well, does 9 go into 63? Yeah. So I'm thinking that's my greatest common factor. They have an s in common, just one s in common. So I think my GCF is 9s. If I really want to make sure, 9s can break down into 3 times s. 63s cubed can break down into 7 times 9, but 9 breaks up into 3 times 3, and then I have 3 s's. So what they have in common is they have in common this pair of 3's, they have in common that pair of 3's, and they have in common an s. So my GCF is 3 times s. So I was right when I said 9s. Number 62, the length of the rectangle at the right is 3 feet longer than its width. Write a polynomial that represents the area of the rectangle. Find the area of the rectangle when the width is 5 feet. Area of a rectangle is base times height. So my base is x, my height is x plus 3. So if I distribute that x times x is x squared, x times 3 is 3x. So my polynomial is x squared plus 3x. And if I wanted to find the area when it's 5, I just plug in a 5. I would do 5 squared plus 3 times 5. 5 times 5 is 25. 3 times 5 is 15. 25 plus 15 is 40. And that would be 40 square feet, because that was area.